So we're going to be looking at how we can use the ideal gas law, PV equals nRT, to do calculations. So the first example is I have a 3.5 liter balloon that has a pressure of 1.2 atmospheres. A person sits on the balloon until the volume decreases to 1.6 liters. So it goes from 3.5 to 1.6. The balloon will pop if the internal pressure exceeds 2.1 atmospheres. Will the balloon pop? So understood is that I'm looking for what the final pressure is going to be and seeing that if it's above 2.1, the balloon's going to pop. So here's how I start. I start out with my ideal gas law, which is PV equals nRT. And everything that remains constant I put on one side. Well, luckily, what's remaining constant, the moles and the temperature and R always does, are already on one side. So a constant times a constant times a constant is another constant. So I can just say PV, any combination of PVs, even if I change them, will remain constant in this case. So this P times this V will equal a constant, and that constant will be the same constant as the new pressure times the new volume. So because they're all equal to the same constant, I can keep them equal to one another and say my initial pressure and volume, or P1V1, is going to be equal to my new pressure and volume, or P2V2. So I set P1V1 is equal to P2V2, and then I isolate for my variable that I'm looking for, making sure that it's in the numerator. So that just involves, in this case, dividing both sides by V2. Now I plug in my numbers, and because I've color-coded it, it makes it nice. So V2 is 1.6, and these two are going to be P1 and V1. The 3.5 times 1.2 divided by 1.6 gives me 2.625 atmospheres. Sadly, that's greater than 2.1 atmospheres, so the balloon will pop. Example number 2. A balloon has a volume of 2.8 liters, pressure of 3.0 atmospheres, and a temperature of 27 degrees Celsius. So I'm changing volume, pressure, and temperature. The balloon rises to where the pressure drops to 0.8 atmospheres and the temperature to 17 degrees Celsius. So what will the new volume be? I take PV equals nRT, I bring all the variables to one side, everything becomes a constant, and then I just label P1, V1, so the 1's on this side and the 2's on this side. So then I have to solve for V2, so I keep that to the side. It's already in the numerator, so that's good. So I multiply both sides by T2 over P2, and I get V2 is equal to P1 times V1 times T2 divided by T1 times P2. Now, what's really important is that you have to remember that I have to convert everything to Kelvin when I'm working with gases. So when I put these in, I have to make sure that the 27 degrees Celsius gets added to 273, and that 273 gets added to the 17 degrees Celsius here. So again, I'm showing all my work here so that when I go back to check, I can be sure that, oh yes, I actually did change to Kelvin. And then I multiply it through, and what happens is that my balloon has expanded to a volume of 10.15 liters.